So in this video we're playing around with electromagnets. I'm going to show you how I built this electromagnet drill press vise. It's really simple to use. You come along with your piece of steel, put it on the bed, turn the magnet on, it's held firmly in place, and then once you're done, turn the magnet off and the steel just comes away like that. It is really useful and I'm going to show you how to build one. This video is proudly sponsored by DuraWeld. DuraWeld provides quality welding and fabricating equipment, from stick, MIG and TIG welders to plasma cutters and CNC machines. They also stock all the welding consumables you need to get your job done right. So whether you're a DIYer in the shed like myself or a professional needing industrial equipment, DuraWeld has you covered. Visit them today at duraweld.co.nz, and a big thanks to DuraWeld for sponsoring this video. In my last video I showed you how I modified a microwave oven transformer into a powerful electromagnet with a clamping force of more than 300 kilos. If you want to watch that video, click the link in the corner of the video, or it can be found down in the video's description. For this build I'll be using two electromagnets. To begin the build, first I removed the windings from both of the magnets. Drill press tables come in a wide variety of sizes. If your drill press table is smaller than mine, you may want to consider using a single electromagnet or perhaps two smaller electromagnets. Naturally, when we are using the magnetic vise, we want to avoid drilling into the magnets themselves, so they are spaced apart and a piece of pipe is placed between the magnets to allow the drill bit to plunge into the pipe. I measured the table and worked out what size I wanted my vise to be. I chose to use 50 by 50mm angle iron to make the vise frame. To connect power to the magnet windings, I've chosen to use 4 binding posts that I will mount onto the side of the vise frame. Now when it comes time to weld the two electromagnetic chassis together, we need to make sure that they're both parallel with one another. We don't want them on wonky angles when we're welding them. So to prevent them from warping while I'm welding, I've got a trick up my sleeve. Right, so now I have all my work pieces firmly clamped down to this piece of I-beam section. Should stop them from moving and warping while I weld them. Alright, let's get welding. A quick check with the ruler showed the magnets and pipe were fairly straight, so now I can move on to welding the frame around the magnets. Marking ink is applied to reveal any low spots during the milling process. Since I have a CNC mill in my workshop, I decided to skim the top of the vise. Strictly speaking, this step isn't needed, but since I have the equipment, I figured I might as well do it. I decided to add a cover over the connectors to protect them from metal shavings. A couple of welds were milled away, so to add strength back into the vise, blind holes were drilled and then backfilled. At this point the metalwork was done, but before I proceed to fit the coils, first I had to work out how much resin was needed to fill the void space. An easy method is to fill the void space with something like rice. I realise the windings aren't fitted and the centre pipe that is filled with rice doesn't require any resin. However, it's better to mix up slightly more resin than not enough, so this didn't bother me. After scooping up all the rice, I measured the rice by volume, which worked out to be 1000 mils, which I'll note down for use later. Next, sandpaper was used to remove the insulation from the winding wire ends. A ferrule was used to crimp the wires together. The wire was wrapped around the binding posts and plenty of solder was used to make a solid electrical connection. Now I needed to prep the vise for the resin pour. Next I flipped the vise and applied a bead of silicone around the base. thin sheet of polycarbonate plastic was then pressed down onto the silicon to make a watertight seal. So the resin doesn't fill the centre tube, I cut another section of tube and placed it on top. I used more silicon on the inside to temporarily seal the tubes together. I then applied masking tape around the edges of the vise. The reason the extra tube and masking tape is needed is because the resin shrinks as it cures. So if I were to pour the resin up to the top edge of the vise, when the resin cured, it would shrink enough that the bed would no longer be flat. To avoid that from happening, I'm going to pour enough resin that there is about 2 to 3 millimeters of resin above the bed of the vise. Later I can sand off the excess resin and achieve a relatively flat bed. Next I used hot glue to seal the tape to the vise. This might seem like overkill, however the resin I'm using is polyester, which means it can dissolve some adhesive such as masking tape. And if the masking tape fails, well, I would have a huge mess to clean up. I cut some expanded alloy mesh into strips and used it to reinforce the resin where it's going to be thin over the windings. When it comes to resins, there are plenty of options available on the market, but the resin I've chosen to use is a product called Clearcast, which is a polyester based resin. When choosing a resin, make sure to thoroughly read the instructions. Some resins can only be poured in thin sections, which would require several pours to fill my vise to the top. I chose this particular resin as it should be okay to fill my vise in a single pour. I poured out 1000 ml of resin and added the hardener according to the instructions. When pouring the resin, it's a good idea to pour the resin on the bottom of the mould and let the mould fill from the bottom upwards. This helps avoid trapping air inside the resin. I left it overnight and the next morning I was greeted with a couple of cracks in the resin. These cracks were likely due to the widely varying thickness of the resin and leading to uneven contraction as the resin cured. Fortunately, it's not a big deal to fix. I just mixed up a mini batch of resin and filled the cracks. The polyester resin I'm using bonds extremely well to itself even after curing. 48 hours later the resin was cured and I could remove the mouldings. I used a belt sander to smooth out the resin, stopping just shy of the metal framework, and then I moved to an orbital sander to finish off. With the vise complete, the next task was to find a suitable power supply and sort out the wiring. I used a small plastic enclosure to mount the switch into. An important step that should not be overlooked is the use of a flyback diode. The electromagnets are essentially a big inductor. If you have watched my inductor video, you'll know how destructive flyback can be. So I chose to use an SB540 Schottky diode for this application. The diode is connected backwards to the power supply. And if you're not exactly sure how everything is wired together, then I've included a wiring diagram you can download in the description. I've opted to connect my electromagnets in series to limit the current draw on my power supply. But depending on your power supply voltage, you may want to connect the magnets in parallel. With everything finished, I turned on the magnet. I have a length of flat bar on the bed, and I wanted to get a feel for the strength of the magnet. It took a lot of effort to lift the bar vertically off the bed. The horizontal clamping force was also surprisingly good. The weak link being the drill press bed was rotating rather than the steel slipping on my magnetic vise. Next I tried thin wall angle iron. Since the steel is much thinner, there is less clamping force from the magnet, and this meant it was fairly easy to move the steel horizontally. On the flip side, the vertical clamping force was still very good. To improve the horizontal clamping force, I bought a roll of anti-slip tape. Normally this stuff is used on staircases and slippery surfaces to prevent people falling over. Basically it's like 60 grit sandpaper with adhesive on the back. This dramatically improved the horizontal clamping force. Rather than the steel slipping on the vise like before, the entire table was rotating, proving the vise isn't the weak link here. To test if the magnet is strong enough to be used in basically any scenario in my workshop, I'm using a large 13mm drill bit, and I'll be drilling into a short piece of thin wall steel that only contacts a single magnet. In my workshop, this is basically the worst case scenario this vise will see. So let's see if the magnetic vise is strong enough to hold on to the steel during drilling. You might be wondering if the metal shavings stay magnetized and are a real pain to clean up. And no, they don't. Once the magnet's switched off, they just fall off. It was quite interesting observing how the metal shavings reacted around these powerful magnetic fields. So if you found the video useful, give it a like, it helps the channel out massively. If you want to see more videos like this, you know where that subscribe button is. Thank you to all my Patreon supporters for helping make videos like this possible, and I will see everyone in the next video. Bye for now.